Hi everybody, it's Miss Capelli. It should be the weekend and you are logged on YouTube to watch lesson 3.8, Advanced Geometry, Composition of Transformations. So today in this lesson we're going to learn what happens when you do more than one transformation in the same problem. So I'm going to lead you through lesson 3.8. You should follow along with your copy of this lesson. Anything that I'm writing, you can write on your lesson also. And then following the lesson, you have worksheet 7 tonight for homework. So, the first thing that you need to know about lesson 3.8 is the vocabulary sequence of rigid motions. When you see sequence of rigid motions, that means you're going to have more than one rigid motion. The full definition of sequence of rigid motions is a set of rigid motions that follow each other. This vocabulary comes right from the Common Core, and it's used frequently on your Regents test, also in class, sequence of rigid motions. So that just means you're going to have to do more than one. Maybe a reflection, then a translation. So two things in one problem. So here's an example. The graph at the right shows triangle D prime, E prime, F prime, the image of triangle DEF after it was reflected over the x-axis. So this is the image after it was reflected over the x-axis. Part A, graph and labeled triangle DEF, the pre-image of D prime, E prime, F prime. Pre-image is what it looks like before. So basically we're going to go backwards and do the reflection over the x-axis to find out what it looked like before. So I'm going to start with point D. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. There's original pre-image D. E is 1 away from the x-axis, so it's 1 away. F prime, 1, 2, 3, 4. 1, 2, 3, 4. So now I have the pre-image. In addition to having the prime, some students like to number their triangles so they know which one was first, which one was second. Okay, and then we're going to have to do something else. Part B, graph and label D double prime, E double prime, F double prime, the image of D prime, E prime, F prime, after it is reflected through the origin. Reflected through the origin, that's a point reflection. So now we're going to work off of the prime, number 2, and we're going to reflect it through the origin. So I'm going to highlight my origin. And to reflect through the origin, you have to count over and down and then follow that again. Over 1, down 1, 2, 3, 4. Over 1, 1, 2, 3, 4. And we're calling this F double prime. So notice how double prime is built off of the prime triangle. When you do a sequence of rigid motions, you always go off of the newest image to get the next one, unless otherwise stated to go back to the beginning, but usually we're going to go off of the newest image. So that's triangle number 3. Now here's an interesting question. State a single transformation that will map DEF onto double prime. So forget the middle image, forget number 2. Is there a single transformation that would take us from 1 to 3? Single meaning that there is one transformation that can bring us from triangle 1 to triangle 3. So I definitely think that there's one transformation we can do that would get us from number 1 to number 3, and that would be a reflection over the y-axis. Okay, at this time, I'd like you to pause the video, and I'd like you to try number 2. You try. Alright, so you should have paused and tried number 2, a sequence of rigid motions. The first rigid motion was a reflection over x equals -4. The second rigid motion was a reflection over x equals 2. This is what your graph should look like after the sequence of rigid motions, so check your work. I labeled my triangles pre-image is 1, the first image is 2, then the second image is 3. And then the last question, what single transformation would map triangle ABC onto double prime? So if we went straight from triangle 1 to triangle 3, that would be a translation of 12, 0. Something interesting to note on your notes is that we can generalize this. Anytime you do a reflection over 2 parallel lines, that would be equivalent to a translation. As long as your lines of reflection are parallel and you do a sequence of rigid motions reflecting over 2 parallel lines, that will always be equivalent to a translation. Now we're going to go on in the lesson and we're going to do problem 2. Problem 2 is called a composition of transformations. A composition is very similar to a sequence of rigid motions. A composition is when you do a combination of 2 or more transformations The one thing that makes it a little different from a sequence, it has to be in a specific order. And it's written with this notation. This little dot right here means after. So this is telling you reflect in the x-axis after you translate 3, -4. So my little saying is do it in reverse. The second one comes first. You may have seen this notation when you did functions. I believe maybe in algebra you saw this. F of x after g of x. That means you do the second one first. So you just have to remember, if you see a composition, there's a specific order that you have to do. So here's an example. What is the image of point A, 2, 3, under reflection in the x-axis after you rotate around the origin 90 degrees? So let's plot the pre-image. And I'm going to do this one first. Rotate around the origin 90 degrees. So put your pen on the origin turn your paper to the left, 90 degrees positive, counterclockwise, and it would be 3 to the left and up 2. So go back to regular, 3 to the left and up 2 is A prime. Now we're gonna follow backwards from our composition and we're gonna reflect over the x-axis. Now you have to go off of your newest image. So A prime is what we're gonna reflect over the x-axis. 1, 2, 1, 2. A double prime. So A double prime is at -3, -2. Now we're gonna do it in reverse. We're gonna do it the other way and see if the order really does matter. So we're just gonna check. Maybe it comes out the same and we can just do it either way. So now we're gonna check and see if the order really does matter. We're gonna rotate after we reflect. So plot the pre-image. Now we're gonna reflect over the x-axis first. So 1, 2, 3, 1, 2, 3, that's A prime. Then you're gonna put your pen on the origin and rotate 90 degrees counterclockwise, turn your paper to the left. Now you're gonna go off of A prime. So I'm gonna go 1, 2, 3 to the right and up 2. Come back here, 3 to the right, up 2. That's A double prime. So in this composition, A double prime ended up at 3, 2. So what this problem is telling us is that the order does matter when you do a composition. If you switch it around by accident, you're not going to come out with the same answer as if you did it correctly. So the order matters. At this point, I'd like you to pause the video again, and now you're going to do question number 3. You try. You're going to try this composition. Make sure you pay attention to the order. Do it in reverse. The second one comes first. And then make sure you always work off of the newest image to get the next one. And then we'll reconvene in a minute and I'll show you what that should look like. Alright, you should have paused and you should have tried number 3 on your own. And this was a composition that said translate after you reflect. So you should have reflected over x equals 1 first. And then off of your image, you're going to translate that over to the right and down 1. This is your final image coordinates, double prime. This one was a little tricky because everything kind of overlapped each other. So notice how I'm using like a highlighter to do my line of reflection. It's going to help me, distinguish where my line of reflection is. You can shade in your final image if you want, if that's going to help you figure out and visually represent what's going on, because it is tricky because they're all overlapping. Extra notes on this problem, you should have noticed that J, when you did the reflection, was on the line of reflection, so it doesn't move. So J prime are in the same location. We called that something earlier. We called that invariant. Does not change. So when you did the reflection, J and J prime did not change. When you did the translation, it moved over. But just a little side note, if a point lies on the line of reflection, then it's invariant. Okay, at this time, I'd like you to pause the video again, and then the back page of this lesson is just practice. I'm going to show you what I got for these practice questions. I did provide a graph for you. You could have also done it knowing your little rules that we learned. Reflection first. We learned that a reflection over y equals x switches the coordinates, so it's y comma x. So the pre-image is now going to be 1, -4.
Interruption. Any teachers who are bringing their fourth period classes to the Ball in the House assembly. Please arrive quickly so the assembly can start promptly. Thank you.
Okay, and then you needed to take that point and rotate it 90 degrees. We learned that the rule for rotating 90 degrees was negative y comma x. So you take your y, make it 4, and then move the x in that spot. Or you could have done it on a graph. Here's my reflection over y equals x, and then here's my 90-degree rotation. You should get choice 4. Number 2, I'm getting choice 2. Translate first 4 to the left and up 3, and then negative 270-degree rotation. So make sure when you do a negative rotation, the top of your paper turns to the right. 270 would be 3 times. And then the last problem on this lesson is number 3. You should be getting choice 3 for this. You needed to reflect over the y-axis first and then translate. This one was also tricky because everything overlapped each other. One thing that you should notice when I was doing numbers 2 and 3 is you really only have to do one of the coordinates. You don't have to really do the whole composition because it's multiple choice question. Look at your choices for A double prime. None of them are the same, so if you just do the composition for point A, you should be able to choose from there. You don't even have to really do point B at all because of the multiple choice nature of these questions. So after you finish this lesson, you can rewind, watch it again if you got confused, and then you guys are responsible for doing worksheet 7 this weekend. And Angela, Emma, and Ethan are standing right in front of me while I'm videotaping. Say hi, everyone.
Hi.
Hello.
Okay, have a good weekend.